Welcome back to the series of object-oriented programming. In the previous tutorial, we have discussed about inheritance in OOP. Now we move ahead to the next topic of our series, that is abstraction. Abstraction in programming is a fundamental concept that helps simplify complex systems by hiding unnecessary details and showing only the essential features. We try to understand in simple words. Abstraction is used to hide background details or any unnecessary implementation about the data so that users only see the required information. It is one of the most important and essential features of object-oriented programming. We can say that predefined functions are similar to data abstraction. Let me explain in an example. When you drive a car, you only need to know how to use the steering wheel, accelerator, and brakes. You don't need to understand how the engine, transmission, or fuel injection system works. In programming, abstraction enables users to interact with the system through a simplified interface. This means they don't need to worry about the internal workings of the system. Abstraction hides the complexity, allowing users to focus on what they need to achieve. Look at simple example. We try to make abstract class in Java. Before starting class, add abstract keyword. It identifies an abstract class. Keep in mind, abstract method has no implementation. Only non-abstract method has implementation. Let's have a look on key concepts of abstraction in object-oriented programming. Number 1 concept is hiding complexity. Abstraction hides the internal implementation details and shows only the relevant functionalities to the user. This allows the user to interact with the system without needing to understand how it works internally. Second concept is essential features. Abstraction focuses on essential attributes and behaviors, allowing developers to work with simplified representations of complex entities. This enables efficient code management and development. Our third and last concept is interface versus implementation. In abstraction, there is a clear difference between the interface, what the system does, and the implementation, how the system does it. The interface is what the programmer interacts with, while the implementation is hidden behind the scenes. Now let's to the next topics, types of abstraction. There are two types of abstraction. First is data abstraction. This focuses on exposing only relevant data to the outside world, often through getters and setters, while keeping the internal data structure hidden. We try to understand data abstraction with the help of an example. Create a bank account class and set balance property type as private to prevent outside interference. Set its initial value 0. Now we create two methods, setter and getter. Setter method is set balance, and getter method is get balance. Setter method is just used for put value, and this value is assigned to property whose type is private. Getter method is used to get the value that was assigned to the property. Now we see how to implement the bank account class into another class. Create an object of bank account class. Set the balance amount with setter method, that is set balance. Now we get balance amount with the help of getter method, that is get balance. Now we see second type control abstraction. This involves using functions or methods that hide the details of how tasks are performed. The user knows what the function does, but not how it achieves that result. What is control abstraction? See in an example. We create a circle class and constructor with param to set the radius value. We will use getArea method for implementation of circle. In the last, we implement circle class. Create an object from circle class and set radius value. We use getArea method to get the area of circle. Now we see full example how we can use abstract class in single or multiple class. Let us create vehicle class. We have discussed in the previous. Abstract class starts with abstract keyword. Abstract method has no implementation. Only non-abstract method has implementation. We create car class and extend it with vehicle class. Keep one thing in your mind. If we use abstract method from parent class, we has to put override notation before the method. Here we are free to apply the data as per our requirement. In this way, we can implement other methods from the parent class according to our requirements. We have discussed this before. An abstract class can be used multiple times with multiple classes. Each class is free to implement abstract methods according to its requirements. Our next topic is levels of abstraction. Let's see and discuss in detail what are levels. Low-level abstraction. In this level, you are close to the hardware and deal with the detailed implementation of how the system works. This includes assembly language or machine-level programming, where you must understand memory management and the system's architecture. Mid-level abstraction. In languages like C and C++, you have a mixture of both low-level and high-level abstraction. While you have access to system resources like memory and pointers, you still have higher-level constructs like functions, loops, and conditionals to manage logic. High-level abstraction. In high-level languages like Python, Java, or JavaScript, you work far away from the hardware and deal with more human-readable code. These languages abstract away complex operations like memory management, allowing developers to focus on solving the problem at hand. Abstract data types. These are high-level abstractions that define how data structures like stacks, queues, and lists behave without specifying how they are implemented. Abstract interfaces. In object-oriented programming, abstract classes and interfaces provide high-level definitions for operations, but the specific implementation is left to subclasses or derived classes. Our next topic is why is abstraction important in programming? Code reusability. Abstraction helps in creating reusable code. Once an abstract interface is defined, it can be used in multiple contexts without needing to rewrite the implementation. Code maintainability. Abstraction hides the complex details of inner working and make it easier for the developers to maintain. Abstraction enables the developer to change the underlying implementation, making updates and bug fixes without affecting the code. Improved readability and simplicity. By focusing only on the essential features and hiding irrelevant details, abstraction makes code more readable and easier to understand. Developers don't need to dive into the inner workings of every component. Reduction of code duplication. By creating general abstract actions, you don't have to repeat code. Instead of writing the same code over and over for different situations, you can make abstract classes or functions that work for different needs. Encapsulation. Abstraction works closely with encapsulation. It is another principle. By abstracting data and functionality, you keep internal data safe from outside interference and only expose what is necessary. Ease of collaboration. When teams work on large-scale systems, abstraction allows developers to work on different parts of the system without needing to know how every part is implemented. The agreed-upon interfaces or abstract classes give clear instructions for building and connecting parts of the system. Security and protection. Abstraction also contributes to security by hiding sensitive or unnecessary details. Only necessary components are exposed to users or other parts of the system, reducing the risk of unintended interference or security breaches. It was all about abstraction in programming. I hope you understand better. Meet you in the next interesting video. Goodbye.